If a circle has a circumference of 16 pi centimeters, what is its area? Okay, so for this one, we need to first write down what the circumference and area formulas are for a circle. So we'll say C is the circumference, and that is 2 pi r for a circumference of a circle. And we'll say A is the area, and pi r squared is the area of a circle. We're given that the circumference of the circle is 16 pi, so I'll say 16 pi is equal to 2 pi r, and I'll solve for r. Okay, so I'll divide both sides by 2 pi, so I get 16 pi divided by 2 pi is equal to r. The pi's cancel, and you get r is equal to 8. Now the reason I did that is because now I can take my r and I can plug in for area. The only thing I need to find the area of a circle is the radius. Okay, so A is equal to pi times 8 squared, or 64 pi. Now for B, if a circle of radius r and a square with a side length of x have equal areas, express r in terms of x. Okay, so given that, we have a circle with radius r, and we'll say area of this is equal to the area of a square with side length x. Now, it's not a rectangle, it's a square, so if the side length's x, then this side length is x too. So first, let's write down what the areas of these two things are. We know the formula for the area of a circle. We just wrote it, pi r squared. Okay, so pi r squared is equal to the area of this square, which is x times x, or x squared, length times width. Okay, and it said express the area in terms of, or express r in terms of x. Okay, so we need to get r by itself. Divide both sides by pi. So you get r squared equals x squared over pi. And to get rid of the square, we do the opposite of a square, which is a square root. Now, typically, when you take the square root of both sides of an equation, you do need to put a little plus or minus here. But since we are talking about the radius and length of a square here, none of that's going to be negative. So we won't have to worry about the negative on that. So we'll just say r is equal to, because the square root and the square cancel, square root of x squared over pi. Now, you might want to clean that up a little bit. You can take the square root of the top and bottom separately. That would be the square root of x squared divided by the square root of pi. Now, just like happened right here, you get the square root and square together. They cancel out, so there's an x on top, square root of pi on bottom. That's probably going to be an acceptable answer. But if you are asked to rationalize the denominator, in other words, this square root in the denominator, this is irrational. So in order to get rid of that, we have to multiply the top and bottom. Here, let me say that is a correct answer. But if in order to rationalize, we need to multiply the top and bottom by a square root of pi. So I'll multiply square root of pi, square root of pi. Anything you do to the top, and you have to do the bottom, and vice versa. Okay. So when we multiply a square root of pi and a square root of pi, that essentially is, let me write the top here, square root of pi squared. Now we know what happens when a square and a square root get together. We've done it twice already in this problem. They cancel out and it leaves a pi. So you can get x square root pi over pi. So that's also a correct answer.